Good morning, IB Math. Get ready, I'm going to get going here. How was the test? Was it all right? Did you do well? I'll get that graded and returned as soon as possible. Today we're going to start Chapter 5. Take out your notes. Here we go. And Chapter 5 is a very different topic. Kindler and gentler, nicer, maybe not so bad, not so intense. It's the first lesson is all about sampling. We'll talk more about that in a moment. But what is the chapter all about? Let's take a look at, I'm going to introduce the chapter here. So, Chapter 5. Chapter 5 is all about analyzing data and quantifying randomness. Analyzing data and quantifying randomness. Analyzing data and quantifying randomness. Analyzing, we should understand what that word is, and A-N-A-L-Y-S, yes, in English it is an S, I know in American it's a Z. Data and quantifying, here's a very important word, quantify. What does it mean to quantify? Think about it as a quantity, as a number we can assign to it. Quantifying the randomness, describing the randomness. And really what this chapter is all about, a better title for this chapter might be Statistics and Probability. The other version of the IB class, they spend a lot of time in this chapter and it gets a lot deeper. As we start to look at this chapter and use some of our calculus knowledge to go a little bit deeper and to analyze some of these things, we will still see a lot of stats and probability in this class. So first, in this chapter, we're going to limit ourselves to something called univariate data. The prefix here, uni, means one. So this is data that's just going to have one set of data in it. It's not like a lot of data we think of, as a bivariate data. That's where we would be comparing X's and Y's, like forest and cutting down trees and comparing how old they are and how big they are. That would be bivariate data because there's two different data sets there. But univariate data is just a single set of data. There's no relationships here. An example would be if we went around the room and I measured the heights of all the students in the class. Or if I went around the room and measured the weights of everybody in the class. Don't worry, I'm not going to do that. And of course, bivariate data is I could compare them, heights and weights, I could compare them. But this is univariate data. We're going to have one set of data that we're going to be analyzing. Before we start and get into it, there are some concepts that I'm hoping that we already know and remember from previous classes. For example, the mean, median, mode, and mid-range. These are measures of central tendency. The mean is the arithmetic average. The median is if I lined up the data set in order, the middle number. The mode would be the most frequently occurring number. And mid-range, if I took the lowest and the highest, add them together and divide by 2. We also want to look at the range. That's a measure of dispersion. And I'm hoping we remember this other thing from Algebra 1, quartiles, and the interquartile range. And we'll get there. We're going to talk a lot about these in the second chapter of this unit. And if you don't remember a lot of these, we'll look at them again. I think we're going to find that a lot of these calculations will take place on the calculator. The calculator is going to do a lot of the work for us. But we've got to know what we're doing, what we're talking about. This chapter's got a lot of terminology in it, a lot of new terminology, some familiar terminology, and then there's going to be some IB terminology. that IB calls things slightly different words, remember. We've seen that before. All right, so let's get into the first section of Chapter 5, 5.1, which is sampling. So in 5.1 sampling, we want to think about, let's consider a problem. Suppose I want to ask the following question. What is the average amount of homework for our high school student? How much average homework? How much is each student doing every night? And I want to find the average. Well, the school population could be over 2,000 students. So that would be a lot of work to try to collect all 2,000. And what about the people that don't respond? So if I wanted to try to find this out, trying to find the average by asking all 2,000 plus students would be a little bit difficult. It would be a little bit hard. Now, the whole population, here's one of our first words. The population would be all high school students. But there's too many, and it might be too difficult to find them all. So we might want to take a subset of them. A subset is better known as a sample. Or a sample is a subset of this population. And how we do this is important, and we'll talk a lot about the reliability and validity of our data. So there's a lot of things we could do. Let's talk about this. For example, we could just go around and just interview all of your friends. Go interview all your friends and come back and tell me the data. Or we should go around and let's just pick a dozen students from each of the age groups, from freshmen, sophomores, juniors, and seniors. Or maybe we could just go and pick a dozen boys and a dozen girls at random. That way we've got equal boys and girls. Maybe we could be a lot more methodical about this. We could assign everybody a number and then use some sort of random number generator to spit out numbers, and then we go find those people and ask them the survey. So there's a lot of different ways of finding a subset. We want our subset to be a good representation of the population. There's advantages and disadvantages to all the different ways that we're going to sample. One of the questions might be, how easy is it to get that sample? What sample size would we use? And if we used a sample size, would it be big enough? Would it be really representative of our population? Would it give the results that are representative of all the students in the school? So we can think about all sorts of different ways. So here's the problem. We want to know what's the average amount of homework for our high school students. We want to know for each student, how much homework are you doing at a night? Pick a night like on Wednesday nights or something like that. So this would be our data. And again, it would be too difficult to try to get the whole population. So we want a subset, a subsample. All right, so let's take a look at the data. Now, the data that we're going to collect, when we collect data, there's really two types of data, two different kinds of data. The data could be qualitative, or the data could be quantitative. Now, qualitative data is sometimes called categorical. And if I asked students, how much homework do you have? And I got responses like, too much, or way too much, or a ridiculous amount, or not enough. You know, there's always that one kid, right? These are words. They don't really give us any, they give us a description, a quality of the data, and it's categorical, but it doesn't really give us a good description, a quantitative. I could assign categories, like I could say way too much, okay amount, too little, or way too little, and have students pick something like that. We've certainly seen data, things like that, where you have to pick one of the categories. That's qualitative data, categorical data. The other type of data is quantitative data. Now, with quantitative data, I want you to think it's numbers. Think about numbers. We're going to use numbers to assign it. We're going to measure it. This is something that could be measured. So if the kid says, oh, way too much, and then we ask, well, how much is that? And the kid says, oh, I've got 20 minutes a night. Another kid says, oh, I've got 60 minutes. So now we're assigning maybe a number of minutes. Because here, one kid could say, oh, I've got way too much. I've got 20 minutes. That's way too much. And another kid say, oh, I've hardly got anything at all. I've only got 20 minutes every night. And our categories, this is not really good quality data. But if we assign numbers, quantitative numbers, this is going to be more reliable. We can do more with this. We can do more analysis here on this data as well. Now, this quantitative data could be discrete or continuous. All right, let's talk about those two words. First, continuous data. Continuous data describes quantities that are measured, such as height or weight or age or the number of minutes that you're doing homework. Discrete data is quantities that are counted, such as the number of t-shirts that you own, or the number of classes that you have, or the number, if I throw a bunch of darts at a dartboard, how many hit the bullseye? So the discrete data is counted. Continuous data is something that is measured. All right. So once we've decided our data, we can work with both of these, measured or counted data. We can do our univariate data with these. Now let's take a closer look at the difference between a population and a sample. So I want to bring these two words up again. First, population. And if we're talking about a population, I want you to think of population is everyone. Everyone that is in the particular thing that I'm interested in. The population consists of every member in the group that we want to find out about. Everyone in the group that we want to find out about. So if we're talking about high school students at a particular school, it would be all of those high school students. If we're talking about finding data on the average salary by women between 20 and 29 in a specific state, then that population would be every single woman between 20 and 29 in that state. So the population is everybody in the group that we're interested about. And the problem is that trying to reach the whole population is a little too much. It's a little too difficult. So that's where the idea of a sample comes in. And again, I want you to think about a sample is a subset of the population. And there's lots of different ways. And when we look at this sample, this subset, we're just going to find out the data from the members in this subset. That's going to give us, and if it's a good sample, if it's representative of the population, then we'll be able to generalize the results into the entire population. But there's the problem, there's the issue. We have to make sure that we've got a good sample, that it's representative of the entire population. And there's a lot of issues about this. How do we make sure we do this? How do we make sure that our sample really is representative of the population? All right, so let's take a look at choosing a sample which would give a good representation of our population. There's some things we have to think about. When we're looking at our sample here, there's a number of different ways that we could choose a sample from the population. There's some key terms and ideas. How do we know if it's a good or not a good? Here's some key words that we're going to use when we're talking about this. First, our target population. The target population is the population we want to take a sample. So the target population is the population from which we want to take a sample. Now, if the video is going a little bit fast, remember I will be uploading the videos to my YouTube channel, AZ Mathman, and you'll be able to access them there again and replay them, look at them, pause them, and go back. The next thing is the sampling frame. The sampling frame. The sampling frame is a list of all the items or people within the target population. So think about it as a list of all the items or people in the target population. A sampling unit is a single member or single item a single unit or single member of the sampling frame. One of the items from that list. The sampling variable that's the variable that's under investigation. And then finally, sampling values. The sampling values are all the possible values which the sampling variable can take. All the possible values that the sampling variable could be. All the different possible values of that sampling variable, all the things that they could be. So, for example, if we go back to the students and asking students questions about the amount of homework, the target population would be all the students at the school. The sampling unit would be each student. The sampling frame would be an itemized list of all the individual students. The sampling variable would be the number of minutes that they do homework. And then the sampling values might be Well, let's see. How many minutes homework? 0, 1, 2, 3, 4, up to 40, 50, 60 minutes, 75 minutes, 100 minutes? I mean, whatever. That would be the sampling values. Think about it as the range of different values, all the different possible values. All right, so this is going to end the first video. So now you've got enough information to go do exercise 5A. Do problems 1 through 4, very similar to the things we've talked about. And maybe give you a minute to look at that, and then we've got another video to play today. So if you want to, we can just kind of go right on to the next video. You can play the next video, or if you want to take a minute to take out textbooks and look at 5A and talk about it, just make sure we get this next video in before the end of class. All right, talk to you again in a minute.